In a previous video, we looked at y equal x to the negative 1 and we plotted them and made some adjustments. We saw that inside the power, if you add or subtract a number, you're shifting the graph left or right. If you add or subtract a number outside the power, you're shifting the graph up and down. Alright? And we saw the graph of x to the negative 1 and made adjustments to it. Now, let us clear our graph paper here, delete these graphs, and we're going to look at what happened when we have a different type of graph, x to the negative 2. So let's do that. X to the negative 2. Y equals x to the negative 2. Let's plot that graph. X raised to the power of negative 2. That's what we have. Alright. Let's make the graph thicker. Let's make the color remain black. Good. So this is the graph of x raised to the power of negative 2. Now you can rewrite that as a graph of y equals 1 over x squared, because x to the negative 2 means the same as 1 over x squared. Remember, your indices, when you raise to a negative power, is the same as 1 over raised to the positive power. Alright? Now, y equals 1 over x squared. Why does the graph behave this way? What happened is this. You can see that if you look at the graph further up, or you could zoom out. Let's zoom out. The graph is getting closer and closer to the x-axis, but not touching it. It's also getting closer and closer to the y-axis, but not touching it. Alright, it doesn't cross these axes. It doesn't cross them at all. Let's zoom back in. Now, if you consider trying to see what happens when x is 0, you get y equals 1 over 0 squared, which is 1 over 0. You cannot divide by 0. It's undefined. So you do not have a value plotted when x equals 0. What about y equals 0? You'd say 0 is equal to 1 over x squared. When you multiply both sides by x squared and divide by 0, you get x squared is equal to 1 over 0. Again, can't do that. You are trying to divide by 0. So you do not have any point plotted on the x-axis when y equals 0. There's no point that is plotted. What you have is the curve gets closer and closer to the x-axis, but never crosses it. It also gets closer and closer to the y-axis, but never crosses it. And in our previous video, we saw that it means the graph is an asymptote to the x-axis and also to the y-axis. So this is what the graph of 1 over x squared is. Alright? The graph of 1 over x squared. Now, let's do a little thing. Let's do a little modification to the graph. Suppose you have this graph. Let's make the other graph in red. Suppose you have y equals 1 over x squared plus 2. Y equals 1 over x squared plus 2. What would that be? Let's plot that graph. 1 over x raised to the power of 2 plus 2. Okay. Let's modify the curve on this graph, making it red 2 and making it thicker. So what you have here is that each point, for example 1, you add 2 to it. 1 becomes 3 because 2 plus 1 is 3. When you have 0.5 here, 2 plus 0.5 gives you 2.5, which is this. So this is a graph. Same graph, 1 over x squared, but you add 2 to it. Means you shift each point 2 units up. Suppose you have another case. You have y equals 1 over x squared. No, not that. I want it to be 1 over x minus 3 squared. 1 over x minus 3 squared. I would expect that this is the black graph shifted 3 units to the right. Would that be correct? Do you agree with that? Let's see. We're going to plot 1 divided by open bracket x minus 3 close bracket raised to the power of 2. Okay, let's make this graph thicker and change the color to green. Which shade of green do I want now? To green. Alright, good. So looking at the black graph, it's the original graph, right? 1, this is x. This point was here, so over 1, and it's now 4. 1 plus 3 gives you 4. Alright, this has shifted 3 units to the right. Here, negative 1 was also shifted. Right? This point here seemed to be at negative 0.5, and it's shifted to here at 2.5. Negative half plus 3 gives you 2.5. So that was correct. It's each point shifted 3 units to the right. Alright. Each point shifted 3 units to the right. Alright, so this is the black graph shows the general shape of y equals x raised to the power of negative 2, which is the same as y equals 1 over x squared, right? But that's the graph that we have. 1 equals y over x squared. Alright, so I'll see you in the next video.